recording. It's Sunday today, and we are continuing down our path through Grand 75. Today, I'm doing problems from week 9. Last Sunday, no, the 2 Sundays ago, I did daily temperatures, gas station, next permutation, and group anagrams. I didn't do valid Sudoku because I think it was the dynamic programming. I'm just saving them for the last. And okay, maximum product subarray. Maximum product subarray. Oops, my internet is slow. What? What? Hmm. Let's put on some. Let's put a timer for 25 minutes, because 25 minutes are enough to know if I can do it or not. Yep. One, and this is second problem is design, add, and search words. Okay. What? Okay. Pacific Atlantic workflow. Okay. Okay. No dynamic programming problem. Okay. Okay. Let's start. Maximum product subarray. Okay. Given an integer array nums, find a subarray that has the largest product. Okay, largest product. I think there was a similar problem with largest sum. Return the product. The test cases are generated so that answer. Okay. This is the array. A subarray has. Okay, let's see. Answer is 6. So 2, 3. 2, 3. 3, 6. 3, 2. Minus. I mean, this is an easy problem. It's not that difficult. For example, I think it's a 2-pointer or something. Dynamic programming. Really? Can't I do something like keep a max variable, and I don't know if it's called a sliding window or 2 pointers, but we basically we basically like go through each element and okay, what is the product of these two numbers? 6. So that's the max product so far, and then I check the next element. Okay, what's the product of this thing? Say minus 6. So I check, is product we found so far into current product, like product found so far into current product, that is minus -6, or only current product. Which one is greater? This one is greater, so we keep this. But no, Okay, let's I think it was something like product found so far into product found so far into current product, right? Either this or this, whichever is greater, uh, that that is our new max. Obviously, this one is smaller, so we do not discard it, and that's okay. So now we cannot do we cannot combine this 4 into current product because well, it's not a subarray. 4 is not in the subarray. Can I get some hints? I think it's I have to use 2 pointers. Kadani's algorithm. Okay, what's -2 into 0 is 0. -2, -2. The result cannot be 2 because it's not a subarray. Yes, it's not a subarray. It's not a subarray. Continues a non-empty sequence of elements within the array. Let's keep 2 pointers. A and B. We'll move the A pointer. So A pointer is here. A into B, and then A into this one, A into B. But that will cause a window. Let me just think of a situation when Kadani's algorithm breaks. Okay, let's see. This. Let's see this. 4 into minus 4 into -1, -4, -4, -4, +16, and +16 is greater than -4. So this I think we don't really have to go about this sequentially. I mean, what I mean that we are only required to return the answer as an integer, not the subarray itself. So maybe there is some trick. Mm-hmm. Let's try to uh, let's try to find the most basic, most brute force solution, and then build from there. Well, I'm gonna say sum is math.max sum I into n. So let's see. Return sum. Okay. Into. I have to think about the negative cases. 3 into 2. 6. 2. 2 into 1 is 1. 3 into 2 is 6. Sum is 6. Then 2 into 6. My negative 2 into 6 is negative 2. Negative 2 into 6 is 12. Negative 12. And 6 is still greater than negative 12. So we choose not to. Let's see. 4, 4, 4. Why 4? 6 negative 4 4 6 2 2 let's try to see the result. Sum 2 6 negative 2 6 really negative 2. So in this part it's 6 and then 6 into negative 2. Why negative 2? Because of oh, okay, got it. 6 become negative. Let's make some I positive before doing this. Into 1 into negative 1. Okay. Then 2 3. Yes, of course. 2 6. But we can't do this every time. Okay. Let's see. Two into 6. Absolute. If I into sum is smaller than 0, then what if we don't consider that? So we don't consider this. 3 into to cut 3 minutes left. Gotta do listen. Real product should be 1 in that case. No. But that will make the 0. Well, if this is the case, then 6 into negative 2, negative 12. Right. So keep the sum. Sum. So sum. I mean sum. And when that happens, so this breaks the Savary rule. So there is no way 4 can be part of the Savary. So that means we can't check the value of 4. So that means okay, at this point we have to break. Is that it? Okay, time's up. Time to find out. Since we have to find the just subarray having maximum product, then your approach should be combination of all elements are positive. Then your answer will be the product of all the elements in the array. Array have negatives. If the number of negative elements is even, then your answer will be complete array, because on multiplying all the negative become positively, then you have to remove just one negative element, and for that you have to check your subarrays to get the max product. I also want zeros, and there will be not much difference. It's just that your array will be divided into subarrays around with 0. Okay, just when you find 0, just discard it. For max min answer, store the max, because before updating your min, max will already be updated. Okay, max is the maximum of current element, and whatever max okay, minus okay previous max. If max is greater than answer, the answer is max. Okay. Just a slight modification of the previous approach, as we know that on multiplying with negative number, max will become min, become max. So why not, as soon as we encounter max min ed, 2 pointers. Okay, I've seen this approach. Prefix product, suffix product. Okay, maybe this one is more intuitive. Answer. If any of the left or right becomes 0, then we update. Okay, 1 L into prefix product 2 and well, let's see if so iterating this array. L, this num2 is not equal to 0, so L is 2, R is R is what, 4, and we check whatever, check which is max, which is the maximum. 4. Okay, next iteration. 2 was 2, so it will become 6. R was 4, it will become -8. And answer was 4, but new maximum is set to 6. Okay, then -2, L becomes -12. This approach is better, according to my opinion. We don't have to worry about the negatives, positives, or negative or zeros, right? R becomes, well, R was -8, 24, -24, and maximum will not change. And let's see. Again, maximum will not change because the negative values. And this is better approach. Sure, works. It works. Okay, so this is the first problem. Next product. Moving on. Design, add and search words, data structure. 25 minutes, reset timer, start timer. Design a data structure that supports adding new words and finding if a string matches any previously added strings. Tree. Implement the word dictionary class. Add word adds word to the data structure. It can be matched later. Returns true if there is any string in the data structure that matches word, or false otherwise. That's all. Okay. Depth first search. Should be familiar with how a tree works. If not, please work. Okay, yeah, I know how a tree works. I've implemented a tree. Well, let's see. Bad. Okay, I think the only different thing from tree version implementing this problem is that in this one we just have to store these strings. That's all. In that problem we were given these strings to search. Okay, let me see. That word, bad, dad, Mad bad dot add. Okay. Non-alphabet characters can be present in the string. Hash map, I'm gonna go with hash map maybe. If only alphabet characters were used, then I could use the array of fixed size array, 26 characters sized array. Consist of dot or lowercase English letters. Okay, then I guess I can still use fixed sized array. Let's see. Tree. Tree. Characters maybe. New tree. 27 because we have a dot this time. What is the ASCII value? What is the ASCII value of dot? Looks like I've forgotten to plug in. What? Java? Just give me the answer. Boolean. Okay, now where do I store this tree object? Adword, 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 search pad. Should return false. Let's see. Tree root is new tree. Okay. Adword. Well, for tree current is root, because I don't want to lose the top level reference. So I want to check for characters in word to to character array we'll need to convert this to an integer index. So ASCII table. $97.97. Lowercase a, lowercase a, lowercase a. Okay, this is lowercase a. Starts from 91. So let's just go with the characters. No need to turn them into integers. Character. So I'm gonna say map dot if map dot no if map dot put character new tree object tree. And my current, I'm gonna move my current map dot get current. And current end of the word. Set this to true. Okay. For searching, it's similar. I'm just gonna take this and will return if we found the end of the word. Well, let's see. there is no map. Current dot characters dot put and current is equal to current dot characters dot get character. Gotcha. Hmm? Yep. We do the same thing here. Just current dot character dot get. Okay. Let's see. Edward, bad. What's happening? Why is it returning false? Bad. Dad. Hang on. If contains if it doesn't contain what? Oh, I forgot to change the code here. If this contains, well, if it doesn't contain the key, then return false. Else current move. Yeah. If my false, well, at least this go. Okay. So bad, dad, and mad both have different starting values. Where there are 3 words in my dictionary, then I look for bad, dad, and mad. Then I look for bad, false. Okay. Then I look for bad, true, fine. Then I look for there seems to be a problem with the dots. What? Dot is not a character. What? What's happening? Just let me just make sure the problem is with the dots. Yeah. Some problem with dots. But why is that? Let's look at the shape of the hash map. And look at the shape of the hash map. And I've messed up the example. Wait, let me say there were 2 dots here. I guess there was 1 dot here. A, B. Oh yeah, there is B, there is no dot. Why is that? Let's okay, we can just convert it to integer. It's not gonna be a big problem. Zero, because it doesn't really matter. Index. Index. Integer. And just do same thing here. Index and index. CH. Yeah. Ooh. Still have problems. What's happening? False. Maybe I don't know. Maybe there is something wrong with the. I don't know. Let's see. What when when this is dot. What is the value of index? Index. Okay. Interesting. Is it? There will be at most two dots in the word. Yeah, I think dot is the special case in this problem, and for some reason, okay, time is up. We gotta check the solution. Very detailed explanation. I don't need detailed explanation. So to design, we can match any character. Hang on. Or I'm so stupid. I won't read this part. I kept reading dot as just like one of the other characters. Word may contain dots where dots can be matched with any character. Okay, so if there is a dot, we can match it to any character. That's so bad. How can I miss that? Okay. Wow. I mean, of course. Because without this condition, there is like nothing really new in this question. It's not really different from the tree version. Question, problem. I keep saying it questions. Ah, God, man. What should I like now? What should I do? Should I sort of like brainstorm for some time before looking up the solution? Okay. Well, how could I have handled this better? Um. Well, if there is a dot that can match to any character, what would I match it to? Any character. Okay, any character. Okay, remove this because I need it. If is a dot, then give me the I don't know, give me any character dot key set dot get Java hash map methods. Let's try to find some appropriate method. I want compute if present. Compute key set. Alright, we can't access the element from the set. Okay, return a collection. Collection. How can I? But I can't even access an element from a collection. Really? Else. Well, I guess I'm just gonna iterate over my for current dot characters dot values, character dot values. And I have already spent so much time on this one, just current tree. I don't know. I continue. This should work. Else I'm looking at solution. Character is none. Yeah, sure. Just gotta make sure that current dot character is not null, and just gotta make sure that character is not null. Yes. Yes. Boolean the result is false. If current is not, well, if current is null, hang on. No. Should we continue? And I'm just gonna break this loop. Okay. Yes. Okay. Don't have so much time. Simple solution. Clean code. Set of strings. Okay. Get list of words that have same. I'm messing up in adword because if the word already exists, the put is new tree. Alright, I think I'm manipulating this value. We will buy current key set, get tree node current child key set. When looking through the key sets, if search wow, index. Okay, what is this? I is the index. Okay, is it getting checked in somewhere? Okay, I don't know, man. Things like I mean, can we avoid this recursion thing? Myth. Wow. Okay, I guess I have to check out some videos about this problem. Okay, let me just, I'll be back. Okay, now that I better know this, I was wondering, could I have used a, could I have used a fixed sized array? I mean, the reason I was using hash map was, because I thought that this dot is, one of the characters. I'll come back to this problem at the end. Let's move on. Pacific Atlantic water flow. Great problem. There is an M into N rectangular island that borders both the Pacific Ocean and the Atlantic Ocean. A rectangular island that borders both Pacific Ocean and Atlantic. The Pacific Ocean touches the island's left and top edges, and the Atlantic touches the island's right and bottom edges. The island is partitioned into a grid of square cells. You're given an element to an integer matrix height, where each cell represents the height above the sea level. Okay. The island receives a lot of rain, and the rainwater can flow into lot of things. Receives a lot of rain. The rainwater can flow to neighboring cells directly north, south. Yes. In less than or equal to current cell's height. Yes. Water flow from any other cell adjacent to an ocean. Water can flow from any cell adjacent to into the okay. So the cells we have at the edges, water from them flow into ocean, return into to the grid coordinates where each cell denotes the rainwater can flow to both. Wait, 1, 2, 2, 3. Okay, so this is our island. Okay, specific ocean. I mean, they could have just said, hang on. We have to return a new grid denotes that flow from cell to both. Okay, this is our 1, 2, 3, 4, 5, 6, 7. The following cells can flow to Pacific. Zero, 4, 0, 4. Okay, because this is where both the oceans meet. So the water from this will flow into this area, and okay. I guess the island receives a lot of rain. Water can flow into cells if the neighboring cell's height is less than or equal to the current cell. So the water at this cell cannot flow to this cell because the height is more in this case. They have equal height, so water can flow here in this area. Okay. Zero, 1, 2, 3, 4. Okay, what's the next? 1, 3, 1, 3, 0, 1, 0, 1, 2, 3 from this cell. 0 1 2 3 4 0 1 0 1 2 3. Okay. 0. This is a question, identity question. Could someone explain this to me? It's so cool. I'm having some trouble understanding this problem. Pacific Atlantic water flow. Pacific Atlantic water flow. The need code make a video on this. Need code. Need code. Need code. Need code. Need code. I think he hasn't. Water from 0 1 2 3 4. Water from this cell. Water from this cell can flow into this cell. Okay, this here is the height is 3, here height is 3. where denotes that from cell to both 0, 1, 2, 3. Okay, let's say we start from here. The height is 1. No, we can't start from here. There is only Pacific Ocean here. So what, like we start from the edges? Or like corners? Okay, 7 has the largest height. So what will slow down from 7 to it can take this direction too, and this direction too. Right, this is a path. Okay, we're sort of creating a path. Let me just look. Good explanation. We need only the cell satisfying the last condition. We start from the cell connected to Atlantic Ocean. Visit all cells having height greater than the current cell. Can only flow from cell to another if the height equal to reach some subset of cells. Next, we start from the cells connected to Pacific Ocean. Repeat the same process. We find another subset. Let's call this 1. The final answer will be an intersection of set A and set B. So we just need to iterate from edge cell, find cells reachable from Atlantic set. I do not like this problem. I mean, I already hate it. Calling 4 BFS. Let's start from here. Is it reachable to this place, to this end, to 5? Well, no, because not from the. Can't go to the right. Can't move here because this height is long, greater. Can't move here to greater. Yes. So we are here. We're checking this. Can we reach here or here from this cell? Well, we can move here, but no, we can't move here. Let's see. We have already checked this. We can't go up. Let's start going down. Here. Yeah, we can move here. No. Can't move here. Cannot move here. Cannot move down. So no, this is also not a valid point. Okay, let's check this. Can't go to the right. Can't go down. Can't go back. Let's check here. Can't go right. Can't go down. Can't go back. Can't go up. Let's see this. Yeah, we can. It's directly adjacent to both the oceans. Okay, this. Well, we can go to the Pacific. We can go down, but we can't go. Can't go here. We can go right, but can't go more right. Okay, can't go back. This one. We can go. Oh, yeah. 4. Wait. Vertical border. Okay. VFS while queue is not empty. Okay, this is typical BFS. X and Y. Oh, all right. Then collect these cells. I'm using the solutions to understand the problem statement better. The matrix is a bit right, and the boundaries are the oceans left. The water on the continent wants to flow out into in the ocean. Numbers in matrix. For every point you have to ask, can the water at this line and this height flow out? 0, 3. 0, 1, up, down, up. Okay. Kind of. At this level, uh, mm, mm, Atlantic. Okay. So at this level, well, here's Atlantic Ocean, and it can also reach Pacific Ocean, because water here can reach Pacific Ocean, so we can just reuse the value from here. Okay, started to make sense. It has started to make sense. Four. Can we reach Pacific from here? Yes. Can we reach Atlantic from here? Going either in this direction or this direction. Well, no, because the neighboring cells values are greater. This 5. Can we reach Pacific? Yes. We can reach from either this direction or this direction. Can we reach Atlantic? Yes. We can go from here or here. 1 4 1 3 0 3 0 1 2 3 2 2. This cell can reach Atlantic water, Atlantic Ocean, but it cannot reach Pacific. Okay. Okay, got it. Finally got it. Man, that was Okay, now how can I do it? Two queues and I add all the Pacific border to one queue and Atlantic border to another queue. So maybe two queues add all Pacific border. So this border. Keep visited metrics for each queue. Okay. In the end, add the cell visited by. Okay, so vertical borders. So adding all these cells which are at the edge to my Pacific queue and adding all these cells to my Atlantic queue. And we just need to check. Pacific queue. While queue is not empty, check 0 0. Check this side, this side, this side, this side. Okay. Visited. Mark. Continue. If x is smaller than 0 or visited. If the next cell I'm looking at, if its height is smaller than my current cell's height, okay. If my x is, well, this is basic bond checking. If you visited this, or if current value is smaller than my current, if the value that I'm trying to go to, if it's the cell I'm trying to flow to, if its height is uh, what is current? Yes, this, right? So I'm checking this. So matrix xy, if this height is smaller, then 1 is 2 smaller than 1? No, then we kind of adding this to my queue. Visited xy. Okay, visited this. Q dot offer. This. Let's see. If x is if x is greater than -1 and x is smaller than bound. It's the one, but bound smaller than matrix dot n and y greater than -1 and y is smaller than m and not visited and matrix it's current non x y smaller than current 0 current do this. Okay. Let's move on. Not, it was not a good problem. Remove nth node from the end of the list. Well, I have done this problem. Uh, to solve a problem. To find the duplicate number, gonna take 20 minutes going to that list. Find the duplicate number. Okay, let's put in here. Given an array of integers nums containing n plus 1 integers where each integer is in the range inclusive, there is only one repeated number in the nums. Find this repeated number. Haven't I done this? How can we prove that at least one duplicate number must exist? Can you solve the problem in linear complexity? 2 pointers, binary search, bit manipulation. There is only one repeated number in the list. Okay, so 2 is getting repeated here. Bit manipulation. Let's say XOR maybe. So return 0. When we XOR something with itself, we XOR a number of we get 0. If we XOR a number with 0, we get that number. Yes. But if we XOR it with any other number, it also has a cumulative property. So can we binary search? Binary search really? Is my array sorted? Two pointers. I like these type of problems. At least I can understand them after reading them for one time. N plus 1 integers. 0. Okay. Then I should return 0. If you XOR the entire thing, it will 0. So, okay, can I get some hints? How can we prove that at least one duplicate number must exist in nums? I don't know. Can you solve the problem linear? Runtime complexity. Yes. For int num into nums. Num into k. K. System dot out dot println. Okay. What is it? From given an array containing n plus 1 integers. Okay, so number has, they're starting from n, and n is inclusive, so 0, 1, 2, 3, 4, 5. So this array should contain integers in this range. Okay. Should not contain every number from this range, but since I've mentioned this, it seems important. So that means that 4 and 5. Now this is my original array given here. Can I have some sort of... I gotta sort this array. Sorry, array is login. Login. Can't use extra space, so there is no cannot keep cannot use an array. Okay, so we have a duplicate number, right? If there was not a duplicate number here, what number would have been on its place? 5, because 5 is in this range. Because 5 is not there, that's why there is 2. But okay, this is not a bug here. Here we have 1, 2, 3, 4, 5. Instead of 3, instead of an extra 3, there should have been a 5. Can I all the integer in nums appears only once except for precisely one integer which appears 2 or more times. Okay. Well, then what is the XOR of this range? Yes. Mhm. Okay, I can do this. 6 approaches. Just give me one. Fort sorters in here. Algorithm, okay. Cool. Most easiest duplicate number. Best solution. Easy job. Smallest solution ever. Can I just get brute force? Yes. To sort the array and check the adjacent. Okay. Using hash set to store an boolean array. Not visited elements negative. Math absolute syntax. Slow fast. We are sure that at least one duplicate is there. Link is the same with problem. Use 2 pointers, the fast and slow. The fast one goes forward 2 steps each time, while the slow one moves only 1 step each time. They must meet the same item. In fact, they meet in a circle. The duplicate number must be the entry point. When visiting the array, just need to find the entry point. Use the point. Okay, cool. So the series inverters produces a sequence similar to the linked list. If there are repeated numbers in the array, take the array. Here 0, 1, 2. Okay, because we can use this element as an index, and when we do that, we reach the same element, right? So 2, right? 0, 1, 2. When we use 2 as an index, we'll get 3 in this case and in this case. Hmm. Right. This is an algorithm. Done today. We don't have any energy left to go back to that tree question. Okay, thank you so much. I mean, has anyone even made it till this part? Okay, thank you for watching this video. Bye bye.